Hi everyone, this video is going to discuss area, and we are going to be finding the area of different shapes, and we're going to stick to some basic shapes. So first of all, what is area? And area is the amount of space that is contained in a certain shape. So in terms of this rectangle, it is that blue shaded region. So we are going to measure somehow how big that is. And if you're thinking about covering that up, we can't cover it up with lines because a line has no thickness to it. So we need to fill it up with little bitty squares. So hence the units of area will be square somethings. So like square feet or square inches and so forth. So we're going to first of all start with a problem here. We have a shop, or actually we have two shops. One shop is 64 by 48, and it rents for $4,800 a month. Another shop is, let's clear that up, 52 by 44, and it rents for $4,100 a month. We want to know which one has a lower cost per square foot. So the first thing we need to know is that the area of a rectangle is your length times your width. And that's a lot of reasons why when we measure dimensions of a rectangle, we kind of measure the length by the width. So if I'm going to look at my two shops, so let's look at shop number one. First thing I'm going to do is find my area of this because I do need a total square foot piece. So I'm going to take that 64 times the 48. So 64 times 48. And I get this 3,072. And now I'm going to put the label on here, which is square feet. And we could write it all out, square feet, because there's more than one, so I say feet instead of foot. Or I can abbreviate, square feet. Or another way to write square feet is with feet squared. So these different methods of writing your units are perfectly acceptable. Now we need to find that cost per square foot. So I'm going to take the cost, because that's the first thing that comes up. And the word per means to divide. So cost per square foot. So my square foot is going to go down here. Cost per square foot. So I'm going to take that 4,800 and I'm going to divide it by 3072. And I see that that is about 156 per foot squared, or per square foot. Now shop number two has a different dimension and a different cost. This one happens to be 52 by 44. So I'm going to do the same thing. I'm going to first of all find that square footage. So that's 2288 square feet. And its cost was that 41. So cost per square foot divided by 2288. And I see that that is about 1.79. It's $1.79 per square foot. So the cheaper one is shop number one at $1.56 per square foot. Also notice that shop number one was larger, so you're really getting more for your money. You're getting a bigger shop at cheaper per square foot. So depending on what I needed, I'd probably rent from shop one. The next little slide is kind of just a historical piece. And what happened before when land was originally designed, and that's why a lot of times these land, if you look at a plot, especially in flatter states like Iowa, things like that, everything is square. And that's because when we originally divided land up, we divided them by a square mile. So a 1 mile by 1 mile square, and that square was called a section. Our next shape that we want to look at is the triangle. And the area of a triangle is given by 1/2 your base times your height. Or we can write it as base times height divided by 2. Whichever is easier for you to do. It will if you do 1/2 times your base times your height, you get the exact same thing as if you took your base times your height and divided it by 2. So here we have a triangle, and they do have some pieces labeled, so they did tell us this was our base. Base does not necessarily mean the bottom, because we could have put a height, you know, if this was a right angle, I could have had this be my height, and that would have been my base. So the base is the side, the length of the side where that perpendicular is dropped to. So here's my height, here's my base. This 15 in this problem is not needed. So we're going to calculate the area, which is going to be my base, which is 18, times my height, all over 2. Or 1/2 your base times your height, 0.5 times 18 times 12. And you'll notice I'm going to do it both ways. You can see it on the calculator that you will get the same result. So I'm going to take this first one, 18 times 12, divided by 2, and I get 108. Here I do the 0.5 times 18 times 12, and I get 108. So they do show you the same thing. Now these were measured in inches, so this would be square inches, or you could write out the words, or inches squared. All right, let's do another example. So let's turn the page here. Okay, now I do not care much for this picture because I'm not exactly sure where the 344 is, if that's this length here or if that's this piece here, and that 51 where that exactly is. So I'm going to do a different triangle, and the triangle I'm going to do is going to look like this. And let's say that this was 7 inches and this was 11 inches and this happened to be 8 inches. Okay, and someone took and found, you know, came straight down. Let's extend this line a little bit, and found that this was 7.5 inches. I mean, these could be way off, but let's just imagine that those were our pieces. And now we want to find the area of this triangle. Now the area of a triangle is 1/2 your base times your height, or your base times height divided by 2, whichever way you like. Now if this is my triangle, my base of the triangle is from here to here. The base of the triangle is the actual base of the shape. Does not include this part here to where that perpendicular comes down, because that is not part of the triangle. So my base is only 7. And my height is this dotted line. Even though it's not part of the triangle, the height is the highest point of the triangle straight down to the same level as where that base is sitting. So for this problem, our base is 7, our height is 7.5, and we divide that by 2. So I'm going to take my 7 times my 7.5, I'm going to divide that by 2, and I get 26.25, and this would be square inches. Another thing to note is we do not change our decimal parts, like if we were measuring something, into parts of a square foot. We leave our answers in decimal form. So we don't write it as 26 3/16, or in this case 26 1/4 square inches. We leave it as 26.25. So we leave things in their decimal form. The last shape we're going to do, and I'm just going to do my 2 nice examples that I can read well, is the area of a parallelogram. Now a parallelogram is when we have 2 sides that are parallel. So this and this side are parallel, this and this side are parallel. And the area of a parallelogram is that base times the height. So now we can measure the height, you know, if this problem's straight up and down here, or we could have turned it, you know, and our height would have been here. So it really does not matter where you measure that height, but it has to be a perpendicular, so that does have to be a straight line that meets with a 90 degrees. So let's do an example. So here we have a parallelogram, or we're going to assume it is a parallelogram. And we are going to measure the area of this to the nearest hundredth of an acre. And they do tell us what an acre is, so we're going to have to do a little bit of conversions, so some review again. But first thing we need is our area in square feet. So this is 512 feet 6 inches, this is 302 4 inches, and this is 319 8 inches. And we are told that from here down, that's a perpendicular line. So the area of a parallelogram is your base times our height. So our height is going to be that 302 and 4 inches. And I'm going to change my 4 inches into decimals. So 4 inches is 4/12, so 4 divided by the 12. And that's 0.33, so I'm going to just go 0.33. That'll be close enough. And the height, or the base, is going to be what it was perpendicular to. So that's this dimension, which is this guy. So that's 512 and 6 inches, which is half of a foot. So I'm going to take that and multiply them together. So 512.5 times 302.33. And I see that that's 154,944.125. All right, and that is in square feet. Now we want to convert that to an acre. So remembering how we converted, so put that over 1, turn it into a fraction. We want to get rid of the square feet, so I'm going to put square feet on the bottom, acres on the top. And 1 acre is this 43,560, which means I'm going to be taking this number divided by that. And divide it by this 43,560. So I have this number still in my calculator. So 43,560, and I come up with 3.56 acres. So again, watch your questions. Make sure you convert them to what they want to be in, and round to whatever they wanted to. So this one was the nearest hundredth, so that's 2 decimals. I did have 557, so I had to round up to 56. Again, that is area. And in our next, I guess we do have one more shape. Sorry. We have circles. So a circle, the area of a circle is given by pi times your radius squared. Now kind of reminding ourselves, diameter goes all the way across, radius is half of our circle. So let's say we have, and I'm just going to find the area of that circle. So this circle is 2 feet 3 inches in diameter, and we want to find the area of that circle. So I'm going to, first of all, I need to find my radius. So 2 feet 3 inches, I'm going to turn it all into feet. So my diameter is 2 feet, that's 24, plus my 3, that's 27 inches. My radius then is half of that, which gives me 13.5 inches. And I am going to find the area of my circle. So my area is pi times r squared. So I need to do this on my calculator. So here we go. So I'm going to take pi. There's my pi button. So I hit my little pi key. Or you can use your 3.15, and I'm going to multiply it by 13.5 and squared. And hit my equal button. And this gives me 572.55. And this was measured in inches, so this is square inches. Now we could convert it to the pounds and everything. I'm not going to. And you can turn it into square feet. We've talked about how to do that. But I want to give you time to actually practice yourself. If you do have questions, please remember you can always email me questions, and I will see you in the next video.